My name is David Meza. I'm the AI ML Research and Development Lead and Senior Data Scientist for People Analytics at NASA. I'd like to thank you for joining me today as I try to walk you through how to develop a knowledge graph within People Analytics. One of the first things we need to think about is, first off, what is a knowledge graph? You're going to hear this term widely used right now. It's become fairly popular across this type of work. And there's been a lot of vendors who are trying to really showcase some of the tools and technologies that they utilize in how to develop a knowledge graph. But simply put, when I take a look at a knowledge graph, it's basically how it's taking a set of domains and interconnecting them through some kind of common relationship. So let me say that again. It's different domains interconnected through common relationships. Now that's a pretty simple definition in my ways, but it basically works for me as I try to look at the different types of data that I have across my industry and across looking at the different types of things I want to connect to it. So I need to think through these domains, and while they may be different, more often than not, you're going to find some commonalities between them, and that is what you're going to use to develop your knowledge graph. So there's going to be a lot of different types of technologies that you can utilize. I prefer utilizing natural language processing as I go through the various corpuses of information I have. And through that, I use things such as text annotation, parts of speech tagging, entity extraction, similarity analysis, sentiment analysis. And of course, within the knowledge graph itself, you've got different types of graph algorithms you can use, such as pathfinding, centrality, and community detection. All of these will help you not only to group your information together, but also to find the answers to those types of questions you want to look at. One of the first things you're going to need to do when you're thinking about knowledge graph is make a determination of whether to use a graph database that is stored primarily as an RDF or resource descriptive framework or LPG label property graph. I've looked at both of these over the years, and for me anyway, label property graphs just seem to make more sense to me. Bottom line is use the one that makes sense to you. So just to compare the two, in the top here, I've got a RDF type of a breakout on the Beatles, the four members of the Beatles, a particular song and an album they've done. Within the RDF, you have 16 nodes and 20 edges to describe the band, the Beatles, in one album and one song. The bottom, you see a label property graph data model of the same thing, coming down to 7 nodes and 8 edges, a little bit smaller in comparison to the RDF, but they introduced the concept of labels. And a label is nothing more than a way to identify a node. So in this case, you see the 4 members of the Beatles, they all have a label of solo artist. The song has a label of a song, the album, Please Please Me, has the label of album on there. Those kind of equate to the type within RDF. Very similar, but there's some differences between those, whereas you have one type for each of those types of nodes in RDF. Within a label property graph, you could have different labels or multiple labels on one node. So for example, Ringo Starr, even though he's a solo artist, I could create another label as drummer and apply that to other bands as I added more and more information into the knowledge graph, and then search through that knowledge graph based on that label drummer. So it gives you some added features you can do. But the other thing about an LPG is you can have properties associated with both the nodes and the relationship. And those properties will come back into play as we start looking to utilize some of the algorithms to pull information out of the label property graph. So, and how do you do all of this? How do you create? There's so many different tools out there. I wanted to showcase here some of the things that I use when I do this. Of course, Neo4j is the label property graph that I primarily use when I'm working through this. I am taking a look at some of the new vector database type tools out there that may be useful within sometimes text similarity. But for this example here, Neo4j is going to be the label property graph. And I've utilized several different types of algorithms within the NLP frame, top to vec, co-reference analysis, even looking at doc to vec, which is a similarity comparison across two different types of text. There's a lot of things you can utilize. Just look at your workflow, try to work through your workflow, how you do your analysis. All of that information can somehow be put back into your graph database. I'm going to show you how I did it in this particular graph database. But to start off, like any other work you're trying to do, your first thing you want to look at is what is the problem you're trying to solve. So in this case, there was a survey done by Gartner back in 2020, and I'm pretty sure it's fairly relevant today. that when they've looked at or surveyed different HR leaders across industries, 66% of them said building critical skills and competencies was one of the most important things that kept them up at night. So that's what we're going to take a look at in this knowledge graph. How to identify different skills within my workforce. And when I build that knowledge graph, I can start answering various types of questions. Some of these questions may be, what is my workforce skill map? How does that workforce look like across the agency? How does it look for us across the geolocations? How are skills grouped across different programs or projects? What kind of skills or competencies am I losing as people attrit? Can I identify adjacent skills? Now, adjacent skills are skills that maybe you should have. If you know one, maybe you should know the other. For example, if I'm as a data scientist, if I know Python, a lot of other data scientists are also learning R or know R. Maybe I should also learn R, and I should have the same type of language in there. So those are the type of things you want to look at when you're trying to see adjacency skills. And the other thing you can pull out of this is, what if I wanted to change careers or look for a different career? Or maybe I'm trying to find individuals within my company that I could upskill or reskill to do a different job. Those are the type of questions you'll be able to answer with your knowledge graph. So before you start doing any kind of knowledge graph, one of the things you want to look at is first identify, is there a foundational data source out there that I can use? And in this case, there was for me. When I'm looking across between the occupations and the occupation domain and the employee domain, I was able to find a data set from ONET, or the Department of Labor, the occupation database here in the United States, that has a listings of a little over 1,000 different occupations. And within that database, they also had information about the various elements that make up that occupation. And those elements are widespread, but they include things such as knowledge to do that occupation, the skills necessary, the tasks that you may be doing in that occupation, things like that. But they also had attributes about that information, such as the importance of that skill or knowledge to that occupation, which I will show later on how that will be used in order to pull some information out. I found some other databases too that were helpful. ESCO was another one, the European Skills, Competencies, and Occupation database. Both of them are open source, and you're able to use that information to set your foundation of your knowledge base. So having that, now that I've got an idea of my foundation, I need to start to build my data model. Your data model is think of it as kind of like your schema for your traditional database, but it's easy to change and update and move around as you need to. And if you have to change it down the road, it's not going to cost you as much impact as you would if you change your schema in your traditional relational database management system. So it's a way to start looking at your data and trying to figure out where are those common relationships. So let's take a look at this. So I have an occupation. And as you hear, I have this node for a data scientist with the label occupation. That's my first part of my data model. Well, what do I know about this occupation? Well, looking at the database, at the ONET database, I know there's a knowledge. This occupation has a particular knowledge. In this case, we're going to look at natural language processing. It also has a skill. In this particular instance, we're going to look at document similarity as a skill necessary for a data scientist to be able to do within this occupation. And it could be an occupation, it could be a job, it could be a project somebody's working on, but it all works the same way. There's a task to do. So in this case, the task would be doc2vec. So this all rounds up by doing this doc2vec task several times and working through that. I learned the skill of document similarity. And if I learn that skill of document similarity as well as other skills within the natural language processing domain, I gain the knowledge or gain the competency within that knowledge area, so that all of those come together. So in this case, this occupation has a relationship to knowledge. It's got another relationship to document similarity, and another relationship to doc2vec. Now here's where the labels come to play within the relationship or the edges. This one has a requires knowledge. This occupation requires knowledge NLP. Well, there is a property we could set to that relationship of importance. Within the occupation database, domain experts have rated the importance that knowledge is to this particular occupation. And that's stored in the database, which now can be stored in your knowledge graph, and you can pull that out later on. So now I have one domain, I have occupations, and I've got that modeled out. But how do I connect that to my employee? Well, if I have an employee, in this case, I've got another node now here as an employee label. Well, reading through his resumes, through their any information, their social information, their publications they may have done, I can see that this person has, proficiency in NLP, natural language process. They kind of have that knowledge with some level of understanding of that knowledge. Well, based again, reading through that information, I see they have some capabilities of doing document similarity as well as utilizing the algorithm of Dr. Vec. But all of that done is through myself reading through that information and making those relationships. I'll show you in a little while how you can use natural language processing in this case to pull that information out of the resumes or publications this employee may have done. But that's not all. Is there something else that we can connect? Because now I've got two domains. I've got data occupation domain. I've got the employee domain. I figured out how to relate them together. But does anything else have the same type of relationships? Well, if you think about it, training does too. Training in text analytics, if I do enough of it, I'll gain knowledge within natural language processing. Within that same training, it'll teach me about document similarity by doing exercises around Dr. Vec. So now I have three various domains connected together in my data model. Now I've got to figure out how to get that information into a graph database. So your model will look something like this as you continue to grow. In this particular case, I brought it up a little bit so you can see the various connections of occupation on your left. The knowledge, skills, and tasks are right there in the middle. The employees on the right-hand side. But as we can build more and more information into our graph model, we can develop things such as job profile, employee profile, or training profile. We can then start developing this and developing applications on top of that to help us do job evaluation tools and add that information back into the knowledge graph, which helps us provide more information to our end users by showing them which jobs have which employees and at what level of skills they have currently in that occupation. And lastly on this thing is now that I can also add where the employee charges to, what cost center, what project, what program are they charging to? And because I know where the employee charges to, I know what skills or competencies that employee has within which work roles, I can now aggregate that all together to tell my managers, based on this project, you have these many employees with these competencies working within this type of work role or occupation. So all of that information was generated by creating this knowledge graph across the three different domains here. So eventually you'll have something like this where at the bottom, it's just stacking layers on top of layers on top of layers until you have all of this information together. The bottom layer here is the occupation database from ONET, which is you bring it up a layer to get a little bit more direct information around the ontology of the occupation. And that's more of a domain area. And then you can go even deeper into it to where you're looking at one specific ontology for one particular work role or occupation to spread that all out. So you continue to add layers on top of your information in order to really make your knowledge graph beneficial and valuable to your organization. And then what you end up is being able to pull out different types of visualizations or analysis such as this. And I'm going to detail a little bit later on, but if you look at right in the center on the left, it's a data scientist. And that data scientist shares about 50% of the same pieces of knowledge as a software analyst. And take a look at the ones that are in blue. You can see there's approximately about 50% of what the data scientist knows, also a software analyst knows. That's going to be useful as you start trying to find individuals that, let's say you want to develop more data scientists. You already have a ton of software analysts that you might be able to, again, reskill or upskill in order to do more data science type work in your organization. You can find these very quickly with utilizing a knowledge graph. And I'll show a little bit of that in a minute. So how does all that work together? So I've given you a lot of information on how you can create the knowledge graph and different types of information, but how do you put that into some kind of workflow? This kind of gives you a very high level look of how I do that. Again, on the left-hand side, I have the occupation information that I've received from ONET and put that into a graph database. By doing that, I've pulled out all the elements of that occupation, the pieces of the information about what knowledge is required, what skill is required, what task is required to be done in that occupation. as well as the various properties for that element. Well, I've taken that textual information about that occupation and its element and created a vocabulary that I use to train against a doc-to-vec model. And what a doc-to-vec model basically does is takes that vocabulary and that model, looking at how those words are similar inside of that model against information about the employee. So I now have that doc-to-vec model based on the occupation information. I can take that employee information, that resume, those publications, anything else I know about them, instead of reading through it and trying to find those relationships, I can now infer it against that model. That model will find information within that employee's corpus of information and find things that are similar to a piece of knowledge, similar to a skill or to a task at a certain threshold we set of similarity. And if it reaches that threshold, it creates a relationship to that piece of knowledge or skill or ability or any of the other elements that are in there back to the employee and puts that in the database. And now I'm starting to build my knowledge graph. Once I have it all in that graph database, I can start using different types of graph algorithms to take a look at skills gap, maybe plan out a career path, looking at individuals over time, what one individual did over time to get to his level of career. How do I, as a new employee or a junior employee, get to that same level? What should my career path look like if I want to pattern myself after this other individual? And strategic alignment model, you can definitely look at how you're aligning your skills and your competencies across your organization very easily by utilizing a knowledge graph. This is my obligatory coding section. This is probably the most I'll show you as far as coding goes. But this is basically, I've done everything utilizing Python. It'll actually scrape the information out of ONET, pull it down from that database and create at least your foundational database with the occupation information. This should be available on GitHub sometime in the next couple of months as I finish up some of the coding. All right, so now that we've got the database built, we've got the information in there, now it's time for us to start doing something. And one of the good things about graph databases and knowledge graphs in general is that over the last several years, they've really started to make graph algorithms and graph data science more viable, or maybe viable is not the right word, but at least more prolific within industry and within some of the databases. So it's easier to use. You don't have to be such an expert in it. There's a lot of different models now that are out there that you can utilize within these databases in order to be able to start looking at your information from a graph perspective. So what does that all mean? Well, here's a very simple example of using a built-in node similarity algorithm within the Neo4j database. So, and remember when I talked a little bit earlier about the data scientists and software analysts, and it looked to me like they were about 50% equal. Well, this is kind of what this algorithm does. It's going to take a look at the common nodes between two other nodes and see to decide how similar they are to each other. So in this particular case, what I've done here is I'm creating what's called a cipher projection, or basically I'm taking a subset of the graph out, putting it into memory so that I can play around with it. So I pulled out various occupations that are IT or technical type occupations within the government. And I've tried to compare, I've also pulled out with that all the various pieces of knowledge associated or necessary to that occupation that has an importance level greater than 0.5. Remember, I talked about attributes that are added to those properties within the relationship. So here's where I'm using that property, that importance rating, to be able to say, I want to know pieces of knowledge that are more important for this particular occupation. Once I've pulled out that graph, I can now write a similarity node or similarity algorithm against it to say, I want to compare my current job. Let's say I'm a management analyst. I want to compare my job to find out what other jobs are out there based on common knowledge that I might be able to do. After running that algorithm, I get a graph that looks something like here on the left-hand side, showing the various different occupations and different things. But the right-hand side, you can also pull it out as a table showing that occupation 1, management analyst, is what I currently have. But I want to do something more technical. What can I do? Well, it shows up right away that I'm 72% similar to information technology project manager. Well, management analyst, that's a lot of project management type work. You can easily slide over and do some project management, but it's not technical enough. Maybe I want to do more about information security. I hear that's a great job to do. It's a lot of advancement in that. I can see that I'm already 47% similar to information security analyst, but because I know how similar I am, I also know what I need to learn in order for me to reach that level of being 100% or being able to do that type of job. So it does two things. It tells me who's close to being the same level as that occupation, but it also tells me what training path I need to take in order to become an information security analyst. So all of those things are now being able to be answered fairly quickly through your knowledge graph. One last little piece of code here I want to show is if I want to find employees that are similar to a particular title. In this case, looking for employees that are close to being computer programmers based on the pieces of abilities they have within the database. In this case, it does the same thing I told earlier. It's comparing nodes against nodes, employees against computer programs with a certain value for the importance ranking. And it pulls out a list of employees that are similar. So now I can look through those employees and decide maybe some of these are people that I can try to train or move around or apply to different types of things. You can use all this type of information to maybe find your right project team based on their competencies or knowledge, or look where you might, again, be able to losing competencies or skills based on attrition that may be happening in your organization. Last thing I want to talk a little bit about is how do you visualize all this? And this is probably the one area within knowledge graphs and graph databases that still needs some more maturity. There's a lot of vendors out there that will help you work through some of this, but there's still, it still has to be a lot of growth. I think there's still a lot of room for growth in how we do this. This is a simple visualization straight out of Neo4j, pulling out information here about a cost center, Earth Science cost center, the employees that are charging to it, and the particular work roles or jobs they're doing within that cost center and what they're charging to. And again, that could be aggregated all the way up to mission, to theme, and to program all the way up to the top. Another way to look at the visualization is through another tool called Bloom, which is again this one is by Neo4j, but it allows you to pull out, again, very quick information utilizing some built-in queries or queries that you write, but you can also write these queries in such a way that you can make individual or your end users put in their own information to pull the information out. So you write a query with parameters that allows you to pull the information out for somebody through some kind of a dialog box or something you want to build. In this particular visualization, I'm showing again an employee who they've charged to and the various different skills they have and what occupation they're doing. I showed this only because if I can do one employee, I can do all employees, and by being able to do all employees, then I can start aggregating that information so that I can show across the different work breakdown structure what skills I have in an aggregate level, and again, showing do I have my skills properly aligned to my project areas. Those are some of the ways you can utilize this in knowledge graph. One other visualization, it's an open source tool called NeoDash, or it's a graph app that you can find. This is actually a very quick visualization of the occupation taxonomy. So if I pull out just an occupation and look at all the various elements, this is how far it would spread out. Very easy to see how wide it goes in all different directions. And these will eventually get tied to an individual or down the line, and you can see how they're all related to each other. Lastly, here is another kind of a dashboard you can create. So you can show management different types of information. On the left-hand side is taking a look at cross-functional skills by program. The little orange nodes there are active employees working in a particular program, charging to a particular cost center in yellow, and they all have this one cross-functional skill systems analysis that are all common. So you can see, well, maybe I have a lot of people with systems analysis type of skills. Can I move this around a little bit to kind of share the wealth or utilize their skills in other projects and help sustain the organization a little bit better? And on the right-hand side is just a tabular output of what is the most important cross-functional skill for these particular occupations. So in this case, for a computer program at a 95% value, the most important cross-functional skill is writing computer programs for various reasons. So these are the things you can start pulling out of your knowledge graph as you develop them. So hopefully I've stuck the landing here. You've gotten some good information on how to build a knowledge graph. I know it's very high level, but if you start looking at this, you can start trying to see how you can connect your domain information together and make those relationships. Please feel free to reach out to me if you have any questions, and I'll be happy to take any answer or any questions on the chat, and I'll try to answer them when I can. Thank you very much, and I hope everybody has a nice day.